Hi class, my name is Manmohan Singh and my journal article presentation is going to be about the overtime work and prevalence of diabetes in the Japanese population. So a little bit background of the study. Um, Japan has been studied for cardiovascular diseases as well as psychiatric diseases over time. There have been several studies that have related the working hours, the long working hours, to developing these risks for diseases. And the study I chose actually chose to take a look at the diabetes because there isn't a lot of research, or at least not available research from Japan, where it studies long hours and the increase of diabetes along with it. Um, The prevalence of diabetes is currently on the incline in Japan, and as we all know, it is a technological, country, especially in places like Tokyo, where a lot of youth does live, and you'll see how that has a lot to do with the working hours that we're going to be talking about for this presentation. So the main, question they want to answer is, do the working long hours, is that connected to diabetes in any way? So the objectives of this study for the authors were to find the association between working excessive overtime and diabetes. And their hypothesis that they've made is that working long hours does lead to increased prevalence of diabetes. And so that's what they will be testing on for this experiment. The targeted population that they used were 11 total companies throughout Japan. But out of those 11, only about 9 of them had the data that was needed, or that actually provided the data for the health checkup exams between the years of 2008 and 2011. So for the analysis on this study, the authors did use a cross-sectional study method. Okay, so the study sample. Uh, so as we mentioned, there were 11 companies that had participated. Uh, out of those 11, only 9 actually had the recorded population that actually took the exams, the wellness exams, to see how or what type of diseases or risks of disease they may be assessed with working overtime. So out of those 9 companies, we had 80,469 employees total. Out of that total, 67,472 were men and 12,997 were women. And the ages they used for the study was anywhere between the years of 15 to 84 years old. Now, the one of the problems, and we will discuss what some of the biases later, is that for the study sample, although they were using 11 companies to start with, which was their target population, but the study sample is actually 9 companies. Out of 9, only 4 of them actually collected um, consistent data over time. So out of the 80,000 some individuals we just spoke about, only 64,434 individuals had the data collected for them. So the final number of participants that they had at the end, once they made even more exclusions, and that's another thing that we'll go over, the final number of the participants they had in total were 40,861 individuals, out of which 35,170 were men and 5,691 were women. Okay, so study sample continued. So out of those initial 80,469, we're talking about the 40,861 that we are going to be using as our group. As discussed in the last slide, where did the other 39,608 individuals go? The recruitment, and we will be discussing those individuals in the exclusion criteria. And so the recruitment method they used for this particular study was data collection. The inclusion criteria, those that they did include in the study, they did have data of working overtime or long hours of overtime, and they had done all the testing necessary through the wellness exam to make sure that they did assess all the risks that were in question. So we're going to go ahead and start about the exclusion criteria first. The population that we spoke about, the 39,000 people that did not count toward the study, they were excluded because they didn't take a wellness test. They had a history of cardiovascular, cerebrovascular, and psychiatric diseases. They had missing overtime data. They didn't take the hemoglobin test, which basically tests for diabetes. They did not do the glucose, they did not provide their glucose data, or they were missing information regarding their anti-diabetic drug. Maybe they already had diabetes, and they were missing their BMI information, their smoking status, their fasting condition, and basically anyone that may be missing the data that they wanted to go ahead and collect for the risks, they were missing, they were excluded. Now, the excluded were, if there's a control group, you could say the excluded participants were the control group because they were used for the study, but they wanted to see how the variables that are collected actually affect the people that are considered for the study. So they are comparable to the case group for the same variables. The statistical analysis they used for this particular study was a t-test for continuous variables. Basically, they're using age, sex, smoking, as well as BMI between those included and excluded. They were looking for the means or the standard error and percentages across overtime category. They were looking for continuous and categorical value variables. And they were looking for a trend association. They were trying to see if there's a linear regression for the continuous variable, as well as a logistic regression for the categorical variables. Now, they did try to look for the odds ratio of developing or the prevalence of diabetes among those that work overtime. The results for those that were excluded, they were more likely to be younger, more likely to be female, tend to be non-smokers, and tend to have low BMI when regarded as a whole group. Now, the univariate results for this was that the odds ratio was high for prevalence of diabetes among those that were working hours. So they were saying there is a direct relationship. Now, the multivariate was, they were trying to look for the prevalence of diabetes among different groups. And they did find that the prevalence of diabetes were higher among those that were younger, that tend to be male, that tend to not smoke, they were physically inactive, or they lacked sleep, or they had a history of diabetes in the family. But among all those variables, the odds ratio of diabetes showed no significance. So one factor was not more likely to be the cause of diabetes than the other. Now, the study conclusion was that it was a U-shaped result. There were, up to 100 hours, there was an increase in prevalence of diabetes, but then there was a decrease over the 100 hours of overtime. So, do I agree or disagree with the conclusion? I largely agree with the conclusion that the authors came up on here. There was a clear um, relationship between working overtime up to 100 hours. But also the decline over 100 is something that I kind of question. How can you really get a U-shaped result? Why is there a decrease? Are there any unexplained confounders that they may have not studied? So I'm not too sure on the inclusion if I actually agree or disagree, but I will largely agree with the conclusion. So the type of bias I think they may have included in their study is the information bias. Just how accurate is the information they had that they provided? What type of audience? What if they had targeted outside the companies? What type of companies were these where the overtime was, was one company more dependent on their overtime than the other? And if it was, for those that were over 100 hours a week for overtime, were they receiving some sort of benefit that kept them healthier than those that were working less than 100 hours of overtime, because they did have a decrease in the prevalence of diabetes? What was their selective processing like? How did they go out there to select? Were they selecting particularly those people that would have met the results they may be looking for? Is it an exaggeration or an understatement? I'm not too sure on, because it's a U-shaped result. I think it's an understatement on the fact that maybe there are more things that they may have left out of the study. So the consideration of impact, it did cover majority of the risk factors for diabetes. It did talk about the BMI, the lack of exercise. It did talk about family history and all of that. But possibly the next study, maybe they can get an equal number of those people that were working overtime, over 100 and under 100 hours. So that way, maybe they have a lot of a lot higher number of people that were working less than 100 hours of overtime. And so that's why there's a U-shaped result. There's a decrease because maybe there's a less number of people that are working over 100 hours, and therefore the prevalence is less among those populations. Now, the applicability to the population, it is yes and no. The U-shaped really doesn't let you say one definitive answer at this point. It does show proof of an increase in prevalence of diabetes, but it doesn't decline. It does not explain the decline over 100 hours of overtime, which, as we mentioned, does raise some questions. Maybe in the future they can. The cross-sectional study method is great, as it does provide the answers they're looking for, as it did on the study. But maybe they can possibly go ahead and start in cohort studies where they can go ahead and study various groups, through various companies, and then compare the two that way. And this is my reference. Thank you so much, and you all have a great day.